In this exercise, we'll address one of the anomalies found in our process. This anomaly is a temperature peak in one of the reactors, and it is sensitive to abrupt temperature changes. For this, we'll divide the exercise into two parts. First, we will search in the past for similar situations where temperature profiles similar to this one have been found. And secondly, for all the profiles or situations found, we will detect the root cause. Starting with the first step, we will go to the search menu and start a similarity search to find similar periods of temperature spikes. To help our algorithm, because we have normal conditions and the temperature peak, which is the most important part for our analysis, we will click and drag over the temperature peak to give it more weight. We can add up to 5 additional weight units to this temperature spike, so the algorithm focuses more on this peak than on the normal conditions. We search over the past few months and find 7 results. We can add these 7 results by adding them as layers to the focus chart. Once we have added all of these layers, we have answered the first part of this exercise. We have found that this event has occurred 7 times in the past few months. Moving on to the second part of this exercise, which is identifying the root cause of these temperature peaks, we will use something called cross correlations. We will look for variables in our process that are correlated with these temperature increases for each of the layers that we have just added. But first, to improve our analysis, we will add a period of totally normal operating conditions. This way, when we search for correlations, we will find variables that have deviated only when there is a temperature peak, but not when conditions have remained normal all the time. For this, in the search menu, we will go to the value-based search and look for periods of normal operation. In this case, this is when temperature is less than 123 degrees. We click search, and we can add, for example, this period of 1 hour and 27 minutes. Now, once we have added these 7 abnormal periods, as well as this normal condition period, we will go to our diagnostic menu, which is represented by the light bulb icon on the left-hand side menu. Here, we'll select the first option of cross correlations. Before running the diagnosis, we'll incorporate in the correlation search an expression that will search for correlations with all tags with variables starting with the letters TM-TSP, which refers to this reactor and this reactor area. We click Diagnose, and we find 5 results, or 5 tags. We see that the first one is an early indicator, meaning that the cause occurs before the effect, in this case the temperature peak, with a delay of 11 minutes and a correlation of 77.7%. This is the cooling water temperature. We'll add it to our chart. We can change our view mode to a stack trend to see it better and see how each time we have had a temperature peak, about 11 minutes before, there has been a peak in the cooling water temperature. However, we see from the dashed line, when there have always been normal conditions, there has been no cooling water peak. This supports and improves the analysis that we have just carried out.